welcome, boys and girls. Welcome, my viewers. Today we are going to learn about current electricity. Just as we said previously, that we have two types of electricity or two main forms of electricity. Whereas we said we have static electricity and current electricity. So in this topic or this lesson, we are going to dwell on current electricity, and we are going to find out what is current electricity. What is current electricity? Remember, static electricity is that form of electricity which is not moving, or it is stationary. So current electricity is that one which is moving, it is in motion, but it must move through something. So this is form of electricity that is carried by or carried through wires and cables. Form of electricity that is carried through wires and cables, which means it must be carried by something. It can't just move. It must be carried by with the wires and cables. I hope you know, you have seen electric poles and electric cables. Those ones are the ones which transfer current electricity. And this current electricity, it can also be stored. We can store it in form of chemical energy, which means it can be stored. It can be stored in form of chemical form, which we say chemical energy. We can store it in chemical form, and this one can be done, for example, in car batteries. Do you know car batteries are charged? We can store them in dry cell. Now, the car battery are the things we call wet cells. So these are places or conditions or devices or tools which you can use to store the current electricity. You can store it in chemical form, where in car battery, and also can be stored in dry cells. And just we say current electricity, it is that one which is moving. So current electricity can move from one place to another. Current electricity can move from one place to another. And this movement, the movement from one place to another is movement from one place to another. This movement is called electric current. So in case you are asked, what is electric current? Electric current is a way through which current electricity moves from one place to another. And just bringing you back to car battery, where, as you said, in car battery, it can be stored in car battery in dry cells, and this one can be also used to run the devices at our home. Now I want us to move to some examples or sources of current electricity. Some sources of current electricity. I want us to dwell on that sources of current electricity, which we also call them sources of electricity. Sources of electricity. Sources of electricity. We have many forms of sources of electricity. For example, if we start with the first one, we have dry cells. Dry cells are the ones we also call torch battery. We can also call them torch batteries. We have number two, we have something like car batteries. We have car batteries. Number three, we have something called generators. Generators. When you talk of generators, generators are put into different categories. We have geothermal, we have hydroelectric, we have wind driven, turbine, and lastly we have bicycle dynamo. These ones fall under generators. Or generators, we have geothermal, driven turbine, hydroelectric generator. This is driven by water. Geothermal generator, driven by heat from the ground. Wind driven turbine, driven by moving air, which is wind. Or we have bicycle dynamo. Bicycle dynamo is a small generator. And lastly, under current electricity, we have what is called solar panel. Solar panel. Solar panel, this one is most used in remote areas, whereas there is no electricity. So these people use solar panel, which convert light from the sun to electric. Now, this is what we are going to dwell on, of starting with the dry cells, that's sources of electricity, which you say these are sources of current electricity, starting with the dry cell. When you talk of dry cell is something which looks like this one here. A dry cell has a negative and positive charge. There is negative and positive. So the positive terminal and the negative terminal, these are, or this is what we call a dry cell. So it must have a positive terminal and a negative terminal. And there's something also you need to know. Now, what about if I have two dry cells connected together, like this one? Like this one I call dry cell. What about this one? Which means here I have two or more dry cells. Now the name, we give it the name battery. Battery, which means where we have more than one, or there are two dry cells and above connected together, they give us what is called battery. Two or more dry cells make up a battery. Two or more dry cells make up a battery. This is what make a battery. So you must know this. There's a say dry cell and you can see the one battery here. Or that's when you check, for example, or something like car batteries. Car batteries, they have like 6 cells, and they are wet cells. So that's why we call it battery, car batteries. So it has at least 6 cells and above. But dry cells put together like in a torch, that one now will make what we say battery. So 2 or more dry cells make up a battery. And a dye cell, I have also told you, it has a positive and negative terminal. Or the positive terminal is marked with a plus, while negative terminal is marked with a minus. Normally, you will realize that each dry cell has a voltage of 1.5, a voltage of 1.5, a voltage of 1.5. So, for example, these two, when connected together, will have a voltage of 3.0. This will have a total of 1.5 voltage as a one dry cell has a voltage of 1.5, which means two will have a voltage of 1.5. Let's also say something small about the battery. Now, which battery am I talking about? I'm now talking of car battery, not battery whereas you're connected two dry cells together. Now, let's talk of a battery whereas you have not torch battery, but a car battery. And I hope most of you have ever interacted with the car battery and its look. Let me just draw a sample here for those people who may find it hard to reflect back or to see what it is. Something like this way. Have you ever seen something like this one? Or now, assuming this is our car battery. So in this car battery, it has, so this one's, these terminals, I told you, most car batteries, they have 6 cells. But this is what we call wet cell, so which is car battery. Car battery, and it's called wet cell. So they also contain liquid chemicals there, and with those liquid chemicals, it is able to produce electricity. So they also have positive and a negative terminal. With the car battery, you will find out somewhere here we have a negative, and here we have maybe a positive terminal. We use this one. And the main thing you need to know about this one, that car battery is rechargeable. It can be recharged, and this one we can use. We can recharge it using geothermal. We can recharge it using hydro. We can recharge it using wind-driven turbine. We can recharge it using solar panel. So we can recharge it using this kind of generators, which means it is rechargeable. Unlike the dry cells, when they are used up, or when you have utilized it, you throw it away. But the car battery, we don't throw it away; we recharge it. Now I want us to come to the next step, which is generators. Let's say something about generators. Generators from the word generate, which means they generate electricity. I want us to say something about these generators. And for the generators, we are going to start by the common ones, which you know, like we have petrol driven generator, we have diesel driven generator, we have kerosene driven generator, this one, the common ones. It's only that nowadays these ones are not. This one are, they don't give that vast energy which we may need. That's why people have gone to hydro, people have gone to geothermal, people have gone to wind. People have gone to wind, geothermal, hydro, because these ones give vast energy. When you come to petrol-driven generator, diesel-driven generator, and kerosene-driven generator, these are medium-size generator. This one is a medium-size generator, starting with the petrol-driven generator, or just like when you talk of a vehicle, or which means there must be a generator there which runs all the things there, and that's the machine there. So a medium generator, the same as diesel driven generator. And also petrol driven generator and diesel driven generators, you'll find them in areas where as people do irrigation. And for the kerosene driven generator, this one is not common because it's not that powerful, but places, maybe theater or places where people watch movies, you'll find they may be using kerosene-driven generators. There, now I'll come to geothermal-driven generator, which is number 4 there. Geothermal driven generator. When you talk of geothermal driven generator, this one uses energy from the earth. When you talk of geo means earth, and thermal is heat, which means heat from the earth. So it's using the heat from the earth to run the turbine. So as the turbine rotates, which means there is ignition which takes place, and that mechanical form of energy is converted to electric, which is there is wire connected to the turbine. So as the turbine turn, that's now mechanical energy, and the mechanical energy is converted to electric energy, which is electricity through the wire. Then now, number 5 there, we have hydroelectric generator. Hydroelectric generator. This hydro means water. Just as we say here, thermal means heat, and now hydro means water. So this one is run by water, running water, flowing water. I know you learned about hydroelectric power, or which this one, there's a dam built, and now the dam does not produce electricity. What produces electricity is what we call the generator. It's called hydroelectric generator, water-driven generator. The work of water is just to turn the turbine, to make the generator run. So it is the generator which produces electricity here. Moving forward, I want us to move to the next one after water or hydro driven generator. Let's move to wind driven generator. Wind driven generator, this is what we call windmill. Some people call it windmill. Windmill. You see, windmill, it is rotating. So the work of the wind, just like water, just like thermal, which is heat, just like petrol. These things do not produce electricity. They run the generator, or they run the turbine, which produce electricity. So wind do not produce electricity. Water cannot produce electricity. Dam cannot produce electricity. Heat cannot produce electricity. Petrol cannot produce electricity. So what produces electricity? Wind-driven generator. What produces electricity? Generator run by water. Generator run by heat. Generator run by petrol. Generator run by kerosene. Generator run by diesel. Those are the things which produce electricity. So when you talk of wind-driven generator, it's the generator which is run by wind that produces electricity here. And now we'll have current electricity. So the work of the wind is just to run the turbine, and the turbine is the generator which produces electricity. And now we are done with the generators. I want to go to a special generator which is bicycle dynamo. Bicycle dynamo. Bicycle dynamo. Bicycle dynamo is a small generator. And I'm repeating, bicycle dynamo is a small generator. Bicycle dynamo is a small generator, and now there is a knob on top of that bicycle dynamo. So what produces electricity here? It is not the bicycle wheel. The work of the bicycle wheel is to run the knob. So as that knob turns at the top of the bicycle dynamo, like you see this one here, so that knob, it is something rotating which does not stop. So as the bicycle wheel rotates, it makes the knob to rotate, and that one makes leads to ignition, and there is connection of the knob and that top to the wire, which makes later that ignition creates heat, and it is turns that from mechanical to electric energy. So that's how bicycle dynamo work. And most dynamos are usually fitted at the hind wheel of a bicycle. And now lastly, under the current electricity, we are going to talk about solar panel. Solar panels, we can also call it solar energy panels. With solar panel, what you must know here is that solar panel converts light energy from the